New era of artificial intelligence in education towards a sustainable, multifaceted revolution. Abstract. The recent high performance of ChatGPT on several standardized academic tests has thrust the topic of artificial intelligence (AI) into the mainstream conversation about the future of education. As deep learning is poised to shift the teaching paradigm, it is essential to have a clear understanding of its effects on the current education system to ensure sustainable development and deployment of AI-driven technologies at schools and universities. This research aims to investigate the potential impact of AI on education through review and analysis of the existing literature across three major axes: applications, advantages, and challenges. Our review focuses on the use of artificial intelligence in collaborative teacher-student learning, intelligent tutoring systems, automated assessment, and personalized learning. We also report on the potential negative aspects, ethical issues, and possible future routes for AI implementation in education. Ultimately, we find that the only way forward is to embrace the new technology while implementing guardrails to prevent its abuse. 1. Introduction. Artificial intelligence (AI) has quickly established itself as a transformative force in a wide range of industries, including education. The development of AI has resulted in an array of advancements and innovations that have impacted many facets of human life. As a fundamental component to societal evolution and individual development, education has had significant benefits from AI breakthroughs. The integration of AI in educational systems is altering the ways in which students learn, teachers educate, and institutions function. By personalizing learning experiences, automating administrative responsibilities, and delivering real-time feedback, AI is revolutionizing the educational landscape, bridging gaps, and encouraging a more inclusive and effective learning environment. Given the importance of integrating AI in education, there is a need to reflect on its implications. Our goal is to study the potential impact of AI on education based on the review of the current literature. We focus on three major themes: applications, advantages, and challenges. The review procedure consists of searching the Scopus database using the relevant keywords. The results are filtered, sorted, and analyzed to extract the pertinent information. We identify several subfields within each theme that are used to categorize the literature and structure the problem in a more coherent fashion. The results are presented in several sections according to the major themes and subthemes. We find that the best way forward is to embrace the new technology while implementing guardrails to prevent its abuse. One of the key applications of AI is natural language processing (NLP). The aim of NLP is to develop intelligent systems that can understand human text and speech. In particular, intelligent chatbots have been increasingly deployed in various industries to provide customer service and support other tasks. The development of modern chatbots began in 2016 and has accelerated up to the current date too. The advent of chatbots has also affected the field of education. 3. A recent survey found that the use of chatbots in education has been steadily increasing. 4. Several studies found that chatbots can improve students' learning experiences and facilitate their education. 5. The turning point in the adoption of AI in society came in November 2022 with the release of ChatGPT. The advanced writing and comprehension abilities of ChatGPT surprised many people, earning a wide-ranging audience and garnering unprecedented attention. It was the first time that an audience outside the machine learning community truly realized the potential and immediacy of AI. The education sector was arguably the most affected by ChatGPT. The potential of ChatGPT to deliver intelligent tutoring systems, on one hand, and as a tool for academic dishonesty, on the other hand, has sparked an intense debate. Educators at secondary and tertiary education institutions have raised the alarm over the possibility of the abuse of ChatGPT by students and called for its restrictions. School districts in Australia's Queensland and Tasmania schools and New York City and Seattle have prohibited the use of ChatGPT on students' devices and networks. Several universities, colleges, and schools are evaluating similar restrictions. 6. However, it appears impossible to prevent the students from using AI. As highlighted in 7, ChatGPT has great potential to provide solutions to college students on a range of tasks from essay writing to code creation. Ultimately, the best way forward is to incorporate AI into the educational system and leverage its capabilities to deliver better learning outcomes for the students. In order to advance the debate over the optimal approach to utilizing AI, in this paper, we investigate its potential benefits as well as dangers. The potential applications of AI in education include personalized learning, intelligent tutoring systems, automation of assessment, and teacher-student collaboration. 4. Personalized learning is possible given the scalability of AI to the entire student population. AI algorithms such as reinforcement learning can be used to dynamically learn about the individual needs of a student and adapt the learning process accordingly. In connection with personalized learning, intelligent tutoring systems can be developed that can actively interact with students, giving valuable feedback. Another impactful aspect of AI is automation of the assessments. Computer vision and natural language processing systems can be combined to automatically grade homework, quizzes, and exams. Automated grading will provide a tremendous relief to instructors, giving them more time to spend with students. AI can also be useful in facilitating teacher-student collaboration by providing various feedback and analytics. The applications of AI in education highlight the potential for huge advantages that are made possible by intelligent systems. The impact of AI can be seen in improved learning outcomes, time and cost efficiency, global access to quality education, and other benefits. Personalized learning and intelligent tutoring systems can help improve learning outcomes for students, especially in underserved populations. The global reach and scalability of AI will allow students from both developed as well as developing nations to benefit from better learning experiences. Automated grading will have massive cost and time-saving benefits in education. Currently, around 40% of teachers' time is spent on grading and related activities. Without the burden of grading, teachers will be able to spend more time with students and provide more learning support. While the applications and benefits of AI in education can paint an alluring picture, it is important to be aware of potential hazards of introducing autonomous systems in education. Since children are more susceptible than adults to misinformation, the use of AI in education should be properly protected and carefully monitored. Potential issues include data privacy and security, bias and discrimination, and the teacher-student relationship. Certain applications of AI, such as personalized learning, require students' personal information. For instance, knowing that a student has a learning disability or a mental health issue will allow AI to select the appropriate approach and customize its content accordingly. While students' personal information can be used for tremendous benefit, it can also be susceptible to privacy and security problems. Anonymizing and encrypting the student data will alleviate some of the concerns. However, a comprehensive strategy is required to address this issue. Another important issue is bias and discrimination. Since AI is trained on public data, it can be exposed to the biases that exist on the internet. In addition, AI algorithms can also inadvertently learn bias on their own. Since there is a significant amount of entropy in the AI algorithms, their behavior could be unpredictable. Minimizing the amount of bias is one of the key challenges in applying AI in education. New technology has historically held potential for misuse. The discovery of nuclear fission created the devastating nuclear bomb. The advent of the internet created the dark web, where illicit and illegal activity can be hidden from the government. However, the society has been able to limit the potential for the abuse of technology through international cooperation and law enforcement. In general, the benefits of new technology outweigh its dangers. Rather than stopping or preventing the advancement of new AI technology in education, it will be more beneficial on balance to integrate it into the curriculum. The example of Khan Academy that has recently partnered with OpenAI to integrate ChatGPT into their systems shows a potential roadmap to adopting AI in education. Ultimately, the only way forward is to accept and embrace the new technology while implementing guardrails to prevent its abuse. The main contributions of the paper can be summarized as follows. Review existing literature related to AI in education. Analyze the potential impact of AI in education. Identify the main avenues and applications, benefits, and challenges of AI in education. Our paper is organized as follows. Section 2 provides background details related to ChatGPT. In Section 3, we present key applications of AI in education. In Section 4, we discuss the benefits of employing AI in education. Section 5 discusses potential dangers of AI. Section 6 describes future directions and opportunities of AI in education. 2. ChatGPT. The release of ChatGPT catalyzed the discussion around the benefits as well as dangers of AI. It marked a turning point in the conscience of many people about their perception of AI. While hitherto AI was regarded as mostly a sci-fi fantasy that existed in a far distant future, the arrival of ChatGPT has suddenly made everyone keenly aware of the legitimacy and tenability of AI. The advent of ChatGPT has increased competition and accelerated the development of alternative AI models, motivating the creation of Google's Bard and Meta's Llama. In this section, we present a brief background of ChatGPT to provide a more complete picture for the discussion. ChatGPT is an AI chatbot that was developed by OpenAI. It was initially released on November 30, 2022 based on GPT 3.5 and subsequently updated on March 14, 2023 based on GPT 4.8. It is considered by many as the most powerful AI tool ever created. 9. ChatGPT is a large language model based on a generative pre-trained transformer GPT that is further tuned via supervised and reinforcement learning techniques. It is able to comprehend and respond to a large variety of prompts with a high level of expertise, as well as carry on a continuous dialogue with the user. It can perform a range of tasks from writing poetry in a specified manner and style to generating computer code according to given requirements. While its responses are not perfect, ChatGPT has achieved unprecedented levels of performance. As shown in Figure 2, its latest release based on GPT-4 is able to achieve above-average human performance on several standardized tests including AP tests, SAT, LEST, and GRE10. The success of ChatGPT has been the inflection point in the adoption of AI in society, including education. It has highlighted the abilities of AI and sparked the discourse about its future. As with most of the existing large language models, including Bard and Llama, ChatGPT utilizes the transformer architecture. Transformer is a sequence-to-sequence neural network model that was originally introduced for language translation, but later adopted for general-purpose language modeling. 11. As shown in Figure 3, Transformer utilizes an encoder-decoder architecture to build a generative model. 11. The key feature of the transformer model is the adoption of self-attention. The attention mechanism provides context for any position in the input sequence, which allows it to process the entire sequence simultaneously. This enables greater parallelization than the recurrent neural networks RNNs and therefore reduces training times. Thus, transformers can be trained on large amounts of data which would otherwise be impossible if using RNNs or long short-term memory LSTM. The encoder portion of the transformer neural network Figure 3 is responsible for generating encodings that contain information about which parts of the inputs are relevant to each other. The encoder consists of 3 major layers: input embedding, multi-head attention, and feed-forward layers. The input embedding layer converts a sequence of input tokens into vectors in the embedding space and adds positional information about each token, which ensures the model can consider the order of elements in the sequence. The embeddings are passed to the attention layer, where the model learns various relationships between the input tokens by weighting their importance based on their positions and semantic content. The output of the self-attention is passed on to the feed-forward layer, which applies nonlinear transformations to further extract higher-level features. These layers are interconnected with residual connections and layer normalization to stabilize and accelerate training. In the end, the encoder outputs rich, context-aware representations for downstream tasks. The decoder functions in a reverse manner from the encoder. It takes the output of the encoder and converts it into sequences. The decoder consists of three major layers: masked multi-head self-attention, encoder-decoder attention, and position-wise feed-forward networks. The masked self-attention mechanism prevents the model from accessing future tokens in the output sequence during training, which ensures that the model is trained autoregressively. The encoder-decoder attention layer then enables the decoder to attend to the encoder's output, allowing it to incorporate the input sequence's contextual information. Finally, the feed-forward networks supply non-linear transformations to refine the generated features, using batch normalization and residual connections to improve the training process. The transformer architecture gives rise to several popular language models, including GPT. In particular, GPT architecture is based on the decoder part of the transformer. It is trained to predict the next token in a sequence given the previous tokens in an autoregressive manner, i.e., it is unidirectional, as it processes the input text from left to right, focusing on learning a language model. The distinguishing feature of GPT models is their scale. While no official information has been released regarding GPT-4, the GPT-3 model consists of 175 billion parameters. GPT-3 was trained on 570 gigabytes plaintext and 0.4 trillion tokens using mostly Common Crawl, web text, English Wikipedia, and two books: Corpora Books 1 and Books 2. After pre-training, the model was fine-tuned using zero-shot, one-shot, and few-shot learning. It has been speculated that GPT-4 was trained on 1 trillion parameters and cost $100 million to train. This study aims to review the existing literature with the goal of examining the potential impact of AI in education. As we enter the era of technology-assisted learning, it is important to take stock of the potential applications, benefits, and dangers of AI. We explore the literature to gain insights into various aspects of the problem.